So now we're going to start to talk about some examples that involve powers of tangent and secant, or cotangent and cosecant. In general, anything that I say as far as a tip for tangent and secant can be interchanged for cotangent and cosecant because their identities and their derivatives are extremely similar. So in this case, we're starting off with tangent cubed times secant to the power of 7. So it's always good to remember the derivatives of tangent and secant in this case. So the tip that I would give you for this one, and we're going to see a couple different examples you can kind of compare, and hopefully that makes sense why this becomes our intuition for this first problem. So the tip that I would offer you here is if the power of tangent of x is odd. So this is sort of regardless of, you know, the secant. If the power of tangent is odd, what we're going to do is we are going to borrow a power of tangent x and secant of x to pair with dx. All right, so we're pulling a tangent and a secant from this. So let's take a look and see what that does to this. So if we were to remove a power from the tangent, that would just leave us with tangent squared. And if we were to borrow a power from secant, that would leave us with secant to the power of 6. And then we'd have I'm going to write this as secant x, tangent x, dx. Now, hopefully, when you look at this, by setting up a secant tangent dx, kind of like what we did with the sines and cosines, we're preparing our future du at this point. So this is going to be our du in a moment. So if our du is secant tangent, what would our u have to be to result in that? Well, in this case, u would have to be secant of x, and our du would be secant x, tangent x, dx. So let's see if this works out for us. So going back in, we've got tangent squared x, and now secant is going to become u to the power of 6, and that secant tangent is going to be du. So here we go. How do we resolve this tangent function? Well, just like with sines and cosines, we're going to be using these Pythagorean identities, and that's why we wanted to reduce that odd power to an even power so we could use the Pythagorean identity with the tangent. So if we do that, we can rewrite this as the integral of secant squared x minus 1, and then we've still got this u to the 6th du, and then if we go ahead and substitute in for u for that secant squared, we're going to be at a place where we can now integrate. So this is going to come down to u squared minus 1 times u to the power of 6 du. As before, we're going to go distribute before we do term by term integration, so that's going to give us u to the 8 minus u to the 6th du. Integrating gives us 1/9 u to the 9th minus 1/7 u to the 7th plus c, and our final answer, if we plug back in secant for u, will give us secant to the power of 9x minus 1/7 secant to the power of 7x plus c. Okay, so the takeaway from this, if you see an odd power of tangent that is got some secants floating along in there, that's going to be the way that it goes. And one last thing that I'll mention, so this would have been the same as if we had a power of cotangent of x that was odd. What we would want to do is we would want to borrow a power of cotangent and cosecant of x. So they really are the same approaches, just using the cofunctions in this case.